Hello guys, welcome back to Maison African Motives, still on Mathematics N3. This platform, we are going to be working on how to simplify and also how to solve some typical questions. So we're actually having some of the questions which I took from the April 2020 question paper for all viewers. So make sure that you join the membership so that you can as well have many other questions or many other questions that you can have from Maison African Motives. So not wasting much of your time, guys. Let us quickly rush through the questions. The first part, it was actually having 3 marks on 2.1, where we are being given to simplify the following. Okay, so this that's the expression that we are given to simplify. So I'm just going to rewrite everything the way we are given so that we can see how are we supposed to do this, how we're supposed to simplify this typical question. Okay, so this is 2.1 where we are given 1 over x plus y to the exponent of -1 minus in bracket we've got 1 over x to the exponent of a half minus y to the exponent of a half, like this, everything to the exponent of a 2. All right, so that's what we are given from this part. Let us just check again and see if truly that's it. So this is x to the exponent of half minus, okay, that's x to the exponent of a half. I hope someone was like, what is happening now here? So that's x to the exponent of a half, like that. So if we are to check from this view, guys, we can see that there is a bracket that we're supposed to expand. And on the other side, from 1 over x plus y to the exponent of -1, we are supposed to apply some laws of exponents because we are raising to the exponent of -1, knowing that x to the exponent of -1 is same as 1 over x. So that means this whole expression can be written as 1 over, so this is the one that was already there on the question. But applying this law, we are going to have 1 over the expression that we are given, which is x plus y. So this is going to be 1 over the expression of 1 over x plus y. We can just put in a bracket to represent that this is a single expression. Okay. On the other hand, here we are supposed to subtract, but there is to the exponent of 2. So that means we are supposed to expand the brackets. On expanding the brackets, be very careful here, guys, when you are expanding these brackets. All right, so let me just do this here so that we can expand our brackets side here. When you are expanding brackets, it's either you're going to use the identities of expanding. You can just do it this way. We know that if we are given, let's say, x minus a, like this, to the exponent of 2, this is going to give us x squared minus 2ax plus a squared. So this is what you're going to have. So in this case, we have got x to the exponent of a half minus y to the exponent of a half, everything raised to the exponent of 2. So as we can see, the first part is x squared. So this is our x and this is our a. All right, so you're gonna have x squared. That is this part of x, the whole of this part here raised to the exponent of 2. Okay, so from your exponential laws, we understand that x to the exponent of a raised to the exponent of b, like this, gives us x to the exponent of ab. Okay, so here we've got x to the exponent of half, which is going to be raised to the exponent of 2 because it's x squared. So what are we going to have now? X to the exponent of a half raised to the exponent of 2. So from this law, we are going to multiply AB means A times B. So that's half times 2, which is a 1. So you're going to have x to the exponent of 1, which is same as x. Okay, so here we are going to obtain x. We move on to minus 2ax. That's minus 2 times a. Our a is represented by y to the exponent of a half. So this is going to be y to the exponent of a half. Then x is represented by x to the exponent of a half, of which this is the same as writing as minus 2x to the exponent of a half, y to the exponent of half, as a like that. You can start with x followed by y. It's one and the same thing. Okay, then we've got plus a squared. So this is going to be plus, take note, this is a squared, and this is our a, where we said it's y to the exponent of a half. So y to the exponent of half to the exponent of 2 is the same way as what we did on x to the exponent of half. It's only that the only thing that changed is the letter. Now it's y, so which means we are going to obtain the same answer just like what we obtained for x, which is x there. So this is just going to be plus y. Okay, so that is the expression that you're going to have if you are to simplify this part. So we are going to have minus into the expression. Take note, the minus is supposed to affect everything. So it's going to affect x minus 2x to the exponent of a half, y to the exponent of a half plus y, like that. Okay, someone might say, okay, these identities, they're difficult for me. I choose to expand with the brackets. Yeah, very well, it's fine, which means from this part, we're going to have 2 brackets of x minus y, x to the exponent of a half minus y to the exponent of a half. So you're going to have 2 brackets of this. Then from these 2 brackets, you can simplify the way that you are used to, x to the exponent of a half multiplied to x to the exponent of half. So from your laws of exponents, you understand that if you are multiplying the bases which are the same, you are going to add the exponents. So let's see if we are going to utilize this space properly. So like I was saying, if you are multiplying the bases which are the same like this, we've got x and x, you add the exponent like that. So here we've got x to the exponent of half and x to the exponent of half. So you add half plus half, which is 1. So this is same as x to the exponent of 1, which is same as x. Okay, we are done with this part. We move on to x and y here. So this is going to give us x to the exponent of half times minus. So it's a minus x. These two are just multiplying each other like this. So it's going to be like this. Okay, we are done with x. We move on to y here. So it's a negative y to the exponent of half times x to the exponent of half, which is the same as minus x to the exponent of half y to the exponent of. You can start with x since the other part we've already started with x, so that you don't confuse yourself. Okay, we move on to y to the exponent of minus half and this other part of y to the exponent of. So it's a negative and a negative, and we know that negative by negative, that's a positive. So y to the exponent of a half times y to the exponent of a half is the same way as what we did to x. You are adding the exponents because the bases are the same. So half plus a half, that is a 1. So this is going to give us y to the exponent of a 1, which is same as y. Okay, in the middle part here, we've got like terms. This is minus 1, this is minus 1, but we don't need to write this, but you must know that that's a negative 1. So you can collect the like terms, that's minus 1, which is minus 2. All right, so that's minus 1, which is minus 2. So this is going to be minus 2x to the exponent of a half, y to the exponent of a half plus y. So as you can see, we are obtaining the same answer, only that this part is a lot of expansion. But if you are in, I think this method is, if it is best for you, then use this method. Okay, because in exam, guys, you're not like, I'm going to use the method that this guy is using or this person is using. No, use the one that is best for you. Okay, on the other hand, we can simplify further here. 1 divided by 1 over x plus y. From our laws, we know that 1 over x. Okay, let's say we've got x here like this. It means the inverse of 1 over x, which is equal to x. Okay, or you can divide the normal way. So 1 over 1 plus y like this is same as this is the whole part. That's our x. So it's the inverse of the whole fraction. So which means our answer is going to be x plus y. Okay. Okay, maybe you do not know this law. Then what are you supposed to do? 1 divided to 1 over x is the same way as writing like this. 1 divided to 1 over x minus y. Where you know that this 1 is same as over 1, the whole number. So you know that if you are dividing, you introduce the multiplication sign, but the moment you introduce sign, you invert the second fraction. So this is going to be on top, this one below. So on top, we are going to have x minus y over 1, of which 1 times x minus y, that is x minus y over 1, which is same as x minus y. So as you can see, we are obtaining the same answer. Okay, this was actually x plus y. So we are obtaining the same answer, which is x plus a y. Okay, so that's what you're going to have, this part x plus y. Then on the other hand, the bracket has to be expanded. So you expand by a negative. So this negative is same as there is a 1 there. So you're going to expand negative 1 times x, which is negative x. Negative 1 times negative 2, that's a positive. So it's going to be positive 2x to the exponent of half, y to the exponent of a half. Then negative 1 times y here, that's a negative y. So do we have any like terms? Yes, we can collect like terms, that x minus x, which is a 0, same like 1 minus 1, that's a 0. Okay, you move on to y, that's y minus y, which is a 0. So which means we are remaining with this middle term, or with this term, which is 2x to the exponent of a half, y to the exponent of half. The other terms, they canceled each other. So that's what you're going to have at the end. And we can't simplify further unless maybe you want to write it in set form, where you are now writing as 2 square root of xy. So you can write it like 2 square root of xy like that. But it's not necessary, because you are not told to use this way to say leave your answer in this format. No, it's just simplifying, so you can even leave your answer at that stage. Okay, so that's what we had from question 2.1. We are going to move on to question 2.2, where we are given to solve for x without using a calculator. Show all your working. And the first part, it's a logarithm. Okay, a nice log that we are given here. So let's write our log down and see what you're supposed to do in this case. So this is 2.21, where we are given the logarithm of x in base of a multiplied to the logarithm of a in base of 3 must give us a 4. Okay, so this is the question. What can we do? That's the question. How can we solve this log? If we are to check here properly, there is something about a. We have got a here on the base. We have got a here, which is representing a number. It's not a base, because the base here is a 3. All right. So this a that we are having is something that is common about this a. So it's easier for us to work with this a as a base, okay? Since we are calculating the value of a, let's just leave this a to be a base. It's going to be easier that way. So leaving this a as a base, we are going to rewrite the logarithm of a in base of 3, this log of a in base of 3, in the same way or format of having a as a base. It's possible, okay? How is this possible? If you have to check from your laws of logarithm, we understand that the logarithm of a in base of b, or it can be logarithm of x in base of y like this, it is equivalent to 1 over, you interchange these letters. So the moment you introduce 1 over like this, you interchange these letters. So this is going to be log y in base of x. You interchange these. The moment you interchange these letters, these two are equal. So we're actually saying these two mathematically, they are equal. You can even substitute numbers to prove what we are saying here. So that means as we want to write in terms of a base of a, it's easier to maintain a to be a base so that we can solve for x. So writing this, which means this part is not going to change, because already a is the base. So it is going to be the logarithm of x in base of a. But we need to change the second log now to write it in terms of a. So knowing that the moment we introduce 1 over, this is going to change. So what I'm trying to say is that if we are to write this, okay, let's just divide. Okay, let's just use another marker, not this one, or even the black one. Okay. So let me show you what I'm trying to say here. If we are to write the logarithm of a in base of 3 in this format, it is going to be 1 over, you interchange just like what we did on y. So if we interchange this, it is going to be the logarithm of 3 in base of a. We have interchanged these two. So that means we can write this as multiplied to 1 over, it's now 1 over log 3 base a. So this is the logarithm of 3 in base of a, and everything is equal to 4. All right. So that's what we have at this extent. Now we can see that we are now having a fraction. Yes, as we wanted to have the base to be the same, to say we've got base A, base A. But it's now making us a challenge because we are now having a fraction. So how do we get rid of the fraction? Just like the way you do, the way you deal with algebra, the way we do with the numbers, we have to cancel out to remove the fraction that is in this case. But in this case, be careful. These two, they are multiplying. So let me explain this part first because some might be confused here. A multiplied to 1 over B like this. It is equal to A over B. Why? A can be written as A over 1. So it's A times 1, which is A. 1 times B, which is B. So if you are given this log here, it's same as over 1. So you're going to multiply log x in base of A times 1, which is going to give us the logarithm of x in base of A. Take note, you're multiplying to 1, so it doesn't change. Everything over 1 times, you multiply, so it's 1 times, which is the logarithm of 3 in base of A. And this is equal to, I hope you understand. So that's what you can do, or you can simply multiply to remove the fraction at that stage. Yes, it's fine, but just to combine so that you can see a normal fraction that you are used to, because you know that this is the same as over 1. So you can cross multiply the two from your cross multiplication, that is 1 times log of x in base of A, which is log x base A, is equal to 4 times the logarithm of 3 in base of A, which is 4 log 3 base of A. Okay, we are getting there. We are getting there. At this stage, there is something that is common that we see. We have got a log of base A, another log which is in base A. So it is easier for us to write these logarithms in this format. The logarithm of m in base of A, if it is equal to the logarithm of n, okay, let's write n here in base of A. As long these are the same, the base, the log base, they are the same like this, it means these two are equal. M is going to be equal to N. So you must know this concept or this law. Can I say it's a law? Let's just say a concept. Okay, you must know this concept. So this only is applied when we have single logarithms. So you must write the logarithm on the left-hand side as a single log, the logarithm on the right-hand side as a single log. So here on the left-hand side, we've got log x base A, which is a single log, it's fine. But on the right-hand side, it's not a single log because there is a number that is multiplying. A single log is like log 3 base A, like that's a single log. So you're supposed to write this in terms of same like having a single log. So what can we do? Which means we have to get rid of this 4 that is multiplying this log. So how do we get rid of this 4? Definitely we need our laws of logarithms here. So I'm just going to use other letters. Maybe you can have these in your formula sheet where they use other letters, which I'm not using here. It's fine. You just have to maintain that what is your formula sheet. But I want you to know this. If there is a number that is multiplying a logarithm like p log m, this p is going to be raised to become the exponent of that log. So this is going to be log m to the exponent of p. So that's the concept. So we've got a 4, which is multiplying the log in this case. So which means we have to get rid of this 4 that we are having here, which is multiplying a log. So it is going to be raised to the exponent of 3. So that's 3 to the exponent of 4, but under the logarithm and also in base of A. So 3 to the exponent of 4, that is 81. You can even use your calculator, guys. 3 to the exponent of 4 is 81. So that means we can write this logarithm as the logarithm of x in base of A is equivalent to the logarithm of 81 in base of A. Remember, it's now a single log. And if it is like this, therefore, let's apply this law. If log m base A is equal to log n base A, m is equal to n. So it means here, we have got logarithm in base of A, which is the same as the logarithm here in base of A. So x is going to be equal to 81 by default. So therefore, x is equivalent to 81. So that is the concept that you just needed there. it is not like always you're going to have it like this. Sometimes you might obtain a condition where you end up having a quadratic equation. You end up having a quadratic equation in terms of x you have to solve. So it's not like always it's like this. Okay, so for you to know how to simplify those typical questions, it needs you guys to work with more questions also. Do not relate with this information only. Do as many questions as possible. Also, if possible, join the membership. By joining the membership, that means you are revising more videos with us as a Mason African Motives family. Anyways, let's see what we had on question 2.22, where we are given again to solve for x, but this time it's a different equation. It's no longer a logarithm. So let's see, how are we supposed to simplify? Take note, all the working is needed, and this is how many marks? 6 marks. The other question was 5 marks, and this one is 6 marks. So I'm just going to rewrite this question again, just like what we did from the other 2 questions. So this is 2.22, where we are given 6 over the square root of, that was 3x minus 1. Minus 1 is equivalent to the square root of 3x minus 1. Okay, so that's it. If we are working with these typical questions, guys, be very, very careful. All right. What you must be careful with is you do not need the square roots. You have to remove those square roots. Okay. But on this type of equation, before you do that, there is a fraction. Yes, you know that you're supposed to clear the square root. So you can start by clearing each and every raised, but it's not proper to do that. So what you do is that you start by removing the fractions that you're given. At least that way it can help us. Okay, so how do you remove this fraction? Minus 1 is same as minus 1 over 1. The square root of 3x of minus 1 is same as over 1. So which means we are having the square root of 3x minus 1 in the denominator. We've got 1, we've got 1. So what is the LCD of the, or the LCM of this? That is the square root of 3x minus 1. So this is just 1, this is that. So the square root of 3x minus 1 has to be multiplied. You have to multiply with this each and every term by that number. So you can combine to have a fraction, but now some of us guys, some of you guys, to simplify the square roots as a single fraction, it can be difficult. So you can avoid that. Yes, you can do that. It's fine. You obtain the same answer. Or you can just start by clearing fractions by multiplying each and every term by the LCD or the LCM. So by multiplying, this is same like over 1. So as you can see, this is going to cancel. You remain with 6. So 6 minus 1 into 1, that is a 1, then times the square root of x minus 3. So it is going to be the square root of 3x minus 1, sorry. All right, let's do this here. So this is the square root of 3x minus 1, which is equivalent to, what are we going to have on the other side? For the square root of this times the square root of this. From your laws of sets, you must understand that the square root of a, when multiplied to the square root of a, you obtain a. You are multiplying the same thing under the square root, you obtain that number that is under the square root. So the square root of 3x minus 1 multiplied to the square root of 3x minus 1, you obtain exactly what is under the square root, which is the 3x minus 1 without any squared. We are saying square root of a times square root of a is equal to a. So that means that is what you're going to have, or you can use this law. Square root of a multiplied to square root of b is equal to square root of ab. That means you can multiply these 3x minus 1 times 3x minus 1. That is going to give us the square root of 3x minus 1 squared. But remember, square root and the square, you just remove the square root, the square, which is 3x minus 1. So you have just obtained the same answer there. We have removed the fractions. Now we are back to a normal equation that we are used to. But this normal equation, it still possesses, or it still contains the square root, where we are supposed to get rid of that square. But before that, we must have a square root written on each side of the equation. That is, just write it on the other side of the equation. So how can we actually do this? This is the question. We can transpose the negative was the square root is carrying a negative. So if we transpose it to the right-hand side, that means we are going to have the square root of 3x minus 1, which is equal to, on the left-hand side, we are going to remain with 6. We transpose 3x minus 1, so 3x is going to be minus 3x, minus 1 is going to be a plus 1. So these are like terms 6 and 1, which is 7. So 7 minus 3x is equivalent to the square root of 3x minus 1. So that's a single square root on the other side of the equation. So we can remove this single square root by squaring both sides. Remember that when you square a square root, you're actually removing the square root. So if we square both sides, that means this and this will cancel. And we are going to remain with 3x minus 1. So 7 minus 3x, you can use that identity. Remember the identity that I told you about a squared minus, I think I explained this in another class. I don't know, but I explained about having this way. Okay, let's just write aside. Okay, here we have got something. Okay, so I've got a minus b, or let me just use x, the one that I used last time, so that I don't confuse you. So x minus I squared, I told you that is the same as x squared minus 2ax plus a squared. All right, so you can actually use this concept, or you can expand the two brackets that you're going to have. 7 minus 3x in one bracket, 7 minus 3x in one bracket. You expand, then collect like terms. Okay, but applying this law, let us just quickly apply the law. It's x squared. This is our x because it's 7 minus 3x like this. Okay, so this is your x, this is your a. So it's going to be 7 squared, 7 squared, x squared. So it's going to be x squared, which is 7 squared. So 7 squared is equivalent to 49. Okay, minus 2ax. So it's minus 2 times our a, which is minus 3x, and our x is represented by 7. So if you multiply 2 times negative 3, that's negative 6 times 7. We are going to multiply, which is negative 42. We are going to have negative 42x there. All right, so that's negative 42x. Then we have got plus b squared plus a squared, which is our a in this case is 3x. So if we raise 3x to the exponent of 2, that's 3 squared, which is 9x squared. So that's what you're going to have at the end. Or you can expand brackets, just like I said, you're going to obtain the same answer if you do that. Now at this stage, you are done all the expansion of brackets, this and that. We were left with an equation now, which is a quadratic equation, because the highest exponent, as we can see from this equation, is 2. So knowing that if we have got this condition, we are supposed to rewrite our quadratic equation. So you can start with x squared. So it's going to be 9x squared minus 42x. So this is 42x. And we've got plus 49 like that. That is the original equation, but we are just rewriting starting with x squared. Then we can transpose the 3x to the other side of the equation, which is going to be negative 3x. We transpose the negative 1 to the other side of the equation, which is going to be a plus 1 is equal to 0. So collecting like terms, 9x squared is going to remain as it is, but we've got negative 42x, negative 3x. So these two are common, x and x here. So negative 42, negative 3, that's negative 45x. Then we move on to the whole numbers. The numbers that we have, this is 49 plus 1, which is 50. So this is going to give us 50 is equal to 0. So all you need is to solve for x, but as you are solving for x, you're going to choose an easiest method or an easiest way, but mostly you are supposed to apply your factorization method, but if not, then you can apply the quadratic formula or completing the square. So from this part, how can we solve this? I'm just going to opt for factorization method, guys. Yes, we can apply our quadratic formula, it's fine. I want you to prove with the quadratic formula, but as for me, I'm just going to use that method that you almost of you hate that method. I don't know why. So we know that on your factorization, if the coefficient of x squared is not 1 like this, you are forced to multiply the first term to the last term. All right, so let me just put in the calculator maybe on the screen so that we can see what's happening. So let me just show the screen here. All right, so we've got our calculator here. So it's going to be 9 times 50. So this is 9 times 50 like this. That's 450x squared. So if you multiply these two, you're going to obtain 450x squared. But you actually need factors of 450x squared that when you add them, they will give you the middle term. Remember, this is your factorization, which is negative 45x. So it's a trial and error. So I want you guys to list all the factors that you can have. List all of them, all the factors. When I say all, I mean all of them. Then from these factors, which one, when you add, you're going to obtain negative 45. So in this case, I'm having these two factors. If we are to multiply negative 30x to negative 15x, that's a positive 450. Let's try, it's a trial and error type of equation. 30 times 15, that's 30 times 15, which is 450. And if we add negative 30 plus negative 15, that's negative 45. So these are the two terms that we actually need. And we have to substitute these terms into the middle term. So it depends whether you're going to start with negative 30x or with negative 15. It's up to you. So in this case, I'm going to start with negative 30. So that's 9x squared, negative 30x, negative 15x plus 15 is equal to 0. So as we know from our factorization, once we put four terms, we can group them into two so that we can find the highest common factor between these two, 9x squared and 30. So what is the highest common factor between 9 and 30? The highest number that we can actually factor out, that's 3. Okay, between x squared and x, which means x is common, so it's going to be 3x. So it will be 3x into 9x squared divided by 3x. 9 divided by 3, that is 3. X squared divided by x, that's x, because those are 2. So it's going to be negative, it's going to be just positive 3x. All right, we move on to negative 30 and 3x. That's negative 30 divided by 3, which is negative 10. So this is going to be negative 10. X and x will cancel. Negative 15x and negative 150. We have to make sure that the bracket is the same as this one. So we're going to factor out negative 5. So that negative 15 divided by negative 5, that's a positive 3. So it's going to be 3x. 50 divided by negative 5, which is a negative 10, is positive, divided by a negative, which is negative. So it's going to be negative 10 is equal to 0. So as we know, guys, from our factorization concept, if the two brackets are the same, which is the 3x minus 10 and the 3x minus 10, you combine these two to just factor out 3x minus 10. Then the rest of the factors here, 3x minus 5 in another bracket. So it gives us another bracket of 3x minus 5. Okay. And this is equal, don't forget, is equal to 0. It's not just factorization. It's a method that we are using to factorize, but knowing that you are solving a quadratic equation, which is always equal to a certain number. So now we can find the values of x from this information that we are given. If we are to transpose, we can just transpose it, just write 3x minus 10 is equal to 0 here, or 3x minus 5 is equal to 0. So if we are to transpose negative 10 to the other side, it's going to be positive 10. Then you divide by 3. So it's going to be x is equivalent to positive 10 over 3, or x is equivalent. If you transpose 5 to the other side, that is going to be a positive. You divide by 3, which is going to be 5 over 3. So what you're going to do is, remember it was another equation that you had and it ended up this way. So you can even test these values if they are actually possible to have the same value that we are given on the other side of the equation. So you just put the value of x and see if you're obtaining the same answer. So you're going to see that when x is equivalent to 10 over 3, guys, this one I want you to do it, use your calculator, substitute. When x is 10 over 3, it's not giving us the exact value as the other on the other side of the equation. But when x is equal to 5 over 3, that's when you're obtaining the value. So x cannot be equal to 10 over 3. So like I said, guys, please test your answers so that you can confirm with me if they are all the same, like they're giving us the same answer, both on the left-hand side or from the values that we have, then it's fine. So guys, that's what we had. We just have to revise as much as we can from Mason African Motives. We keep on part of revision and we keep on working with our question papers our questions from our textbooks, and don't forget to invite as many friends as possible from our colleges where we are so that they join our platform. It can help us as a family of Mason African Motives. So that's it, guys. Till we meet again.